Okay, here we are for lesson 12, interfacing basic and assembly language programs. This is part 1. There'll be 2, maybe 3, at least 2 parts, but maybe 3 or 4 with some different examples. So what we're going to do is show how to interface, a good way to interface these programs at one time. We've done that in the past by having an assembly language program and a basic program and poking some stuff in there. But we're going to actually be able to talk back and forth with these programs. So what we got is a basic program. Do an H screen 2, which is 320 by 192 is 16 colors. We're going to draw some lines, some circles, and boxes. The same thing you did when you first opened up that computer and you said, look at this. Showed everybody you could draw a circle, you could draw lines and boxes, and you were just so happy. That's what this basic program is going to do. But we've got an assembly language program in there. It's going to be running in the background. It's going to tell the MMU to display 320 by 216 colors. Okay, if you notice, there would be 8 extra lines. If you notice, the basic program is working with 192 lines. Our assembly language program is going to work with 200 lines, what it's going to display on the screen. And in that extra 8 lines at the bottom of the screen, we're going to draw some rectangles in the background while the basic programs. These programs are going to be running simultaneously. Okay, they're both going to be running and doing their thing. And our background program is going to be controlled by interrupts by the MMU timer. And we'll get into all of that, but here's an example what the screen is going to look like. Okay, a bunch of random boxes it's going to draw, like basic code you can do. Anybody can do that in basic. And at the bottom you can see all them little rectangle boxes. That's just different colors, a different palette color running across the screen. It'll start at the left and work its way across to the background. They'll run simultaneously. In fact, why don't we, if I can come up and get all my correct screens here, we will demo this. Okay, I already loaded the assembly language program in the basic program, so we don't sit and watch that. So I'm just going to run it. Okay, this is our basic program. It's asked us what do we want to do. So I'll do a 6, and it's going to draw. I think the number is 30 random lines on the screen. Wow. Space bar, and I'll do a 7. It'll draw 30 circles on there. Wow, again. And likewise, 30 boxes, random, all placed anywhere, random colors and random boxes anywhere. Now, the other thing we get to do is we'll init, option number 1, we'll init our assembly language program. Okay, so it's initted now, and nothing has changed on the screen. It's going now. I'll hit 2 to start our background program, assembly language program, and if you watch down the lower left-hand corner, it will start drawing in boxes. Now, the basic program is sitting there waiting for us to enter a new command, while the background program is doing something on the screen. I will do a 7 and draw circles. And if you watch closely as I do these here, okay, I'll do an 8, and while you watch this drawing the boxes, watch the bottom. It's still at the same time drawing them rectangles. They're simultaneous. They're both running together. You notice when I clear the screen, it doesn't clear the bottom part. I'll do some lines again, but that bottom just keeps on running. Okay, good. I can hit 3 and stop it. The background program is stopped now. It's still sitting out there waiting for us, and we'll do this other stuff. And I hit start again, and away it goes. Okay, we can speed it up, slow it down. And we'll get into all that stuff later on, but that's to show you what we're going to be doing. We're going to have these programs run simultaneously. I'm going to hit a 9 to get out of here now. So get back to our other. Okay, our basic program is going to do an H screen 2, 320 by 192 by 16 colors, and it takes a hex 7800 bytes of memory. Excuse me. Remember, them blocks have to be contiguous blocks, and by default they're in 30, 31, 32, and 33. And we're basically going to not worried, but we're going to work with block 33 because that's where our 8 extra lines are going to be. So if we look here at what I'm calling H screen 2, it's 320 by 200 by 16 colors, and it takes 7.00 bytes. Okay, where did we get that from? Let's, if you remember back in our previous one, I give you this screen here. You should still have it somewhere in one of the lessons if you've been following along. And here at H screen 2, the code would be 1 easy, 320, 192, 16 color, takes 7,800 bytes of RAM. The next line down, which is 3 easy, we'll remember that for part 2, we'll be using that 3 easy, but it's 320, 216, and takes 7.00 bytes of RAM. That's where we got them numbers from. So they weren't magically pulled out of the air. That's just the list I gave you. So we know what both of them are at. So if we're just addressing that, regardless where they're at, remember just the contiguous blocks, starting at 0 and it would go up to 7 FFF. That's why our 8 extra lines are in that block 33 in the 7-8 range. Better look at it. Here's that block by itself. And at 7800, which is, this is not to scale, but this bottom line here is where BASIC ends, what it thinks it's doing. No, it knows what it's doing. It ends at 7800. And we told the display is it ends at 7D00, which is the upper line. So this yellow band was inside our block 33 is where we're going to be displaying our little horizontal boxes on the screen. Okay, a refresher. You've seen this many times. You turn the machine on, this is what you get, task 0. If you don't know what task 0 is, you need to go back a few lessons or go through all of them and come forward and make sure you understand what we're doing here. This is the machine, this is the way it sits when you turn it on. If you do a task 1, which we're not really going to use we're going to use task 1 on our clear screen routine. We'll talk about that when we actually look at the code. What we're going to be doing is using that block 33. We're going to be just bringing it forward into this 6,000 range. So block 33, we're going to move it in and be able to address it in this area right there. Okay, so let's start looking at some the interface. How do we interface BASIC and assembly language in a nice, common, orderly fashion? Okay, here's the way that we've done it in the past, or you might have done it in the past. And I know I've done it a lot of times in the past because it depends on the complexity of the programs. If you've got a small BASIC program and 1 or 2 entry points in your assembly language program, this is just fine to do it this way. Well, look at our BASIC program here. It's just some snippets I put in here. The first line is waiting to read a key from the keyboard. If not, just keep looping. To get a 1, we're going to go down here to 206. To 2, we'll go down here to 768. If not, we'll loop back. But just keep looking for a 1 or 2. Not very fancy. This is just for an example. So if we do get a 1, we're going to execute this init the interrupt, okay, at hex E15. And we'll do some more stuff and then come back, okay. Again, if we get a 2, we'll go down here and execute at easy 5 Baker, and that's where the stop routine is. I just grabbed something and typed it in here, so that stuff is not important. Now let's take a look at what the assembly language program would look like. Again, this is just some snippets I cut out of the program. Okay, here's that. We need to remember E15 and E5B. So we'll go over a program at E15 is our init instructions. And don't worry about the code in here. It's just I just cut some stuff out of the program and put it up here. So we could execute it, come here and do this stuff, and then go back to BASIC. We get a 2, would come in here to the stop routine, do this stuff, and go back to BASIC. And everything's fine. Everything works good. And that's all you have to do. That works. I've been using it for years. Now, let's go back and let's just say that this is a pretty big program. And let's just say there's 200, 500 lines in it. It's a complex program, got a lot of stuff in it, and there's a lot of entry points. Because the example, not example, but the actual program we're going to be working with has 7 different entry points into that assembly language program. And some of them we use multiple times. So I think there's like 10, there would be 10 execute statements in our program if we did it this I'm calling it the old-fashioned way, but it's workable. There's 10 of them throughout this whole program, which can be cumbersome and time-consuming trying to define where all of them are. Again, our assembly language program is quite big, so we have to keep track of where all the entry points are. Here's where not problem, but here's where the challenge is. Assume that we want to change this init routine. We want to add one other byte in memory. That would be, let's just use startup background color. Okay, 1 byte. We put 1 byte in up here at the top. We'll just call it color. And we'll say FCB 06. So we're going to use palette number 6 at startup at init time. So we added 1 byte. We reassembled our program. Now that 1 byte, that has changed this here address to E16. And likewise this address here to E5 Charlie. So now we go back to our basic program. We change this to a 6, this to a Charlie, and run it, and everything works good. Oop, went the wrong direction here. That was all fine and dandy, but we didn't do anything with that code. But we got a byte in there, so now we're going to need to use that byte. We have to add some code here in this init routine. So we come down here and we add another instruction. It says load a color. Okay, that would take 3 bytes for that load our color into register A. Okay, so that means this would stay at E16, and then we'd add another 2 bytes, another 3 bytes to this one. So we go back over here and we change this here and add it to this one and run it, and that's fine. It works good. Problem, it doesn't work because we forgot to do something. We loaded A, now we get all I'm thinking that we got to change the room. We're testing, we're building some code, so we got to go back and change it again. We could do that now. Remember, if we got 7 entry points and you keep changing this here, you got to change possibly all 7 of them every time. And I said in our program, we've got 10 examples of it coming over to this code. You have to go back and change possibly 10 addresses every time you make a change. And if you're in a debug mode in this assembly language program, you're going to spend time looking for them. And I know that basic programmers, which I am not, you won't have it sitting real nice. So you'll have everything you can jammed into one line, so you don't, with no notes, so you can get the best performance you can. I'm not knocking, I'm just saying that's the way the basic programs I've seen. People try to get as much on one line as they can for speed without any notes in their remarks in them. So there is a better way of doing it. Okay, I don't know if it's better, but I think it's better. So let's take a look at. Bear with me here to get to the correct basic, the actual basic program. Okay, we're going to use something that's been coming. Color Computer 1, 2, and 3. All basics have always had this called define user. You may have used it, you may not have used it, but what it is it gives you, that's how you get to an assembly language program through, and pass parameters, by the way. You can pass parameters to and from the assembly language program. And we'll actually get into the code. Up here we've got 7 of them, 0 through 6. I think you can have up to 10, 0 through 9 define user statements. We're using 7 of them for clear screen, init, start, stop. You can see them all there. Let's look at this init one. Define user 1. It's at E03. It's our init routine. Now, how do you use that? Okay, we go down here in our program where our init routine is. And we put x equals, and x is If it was returning something from that program, it would be an extra. We're not returning anything. We're just going there to init something. We just say x equals user1 and passing it no parameter or 0, no parameter. So BASIC would hits that. It would go to whatever we set up as user1, which is E003, and it would go there. Let's look at our assembly language program, and here it is, and here's arg at E00, and we've got all these long branches here, the clear screen, init, start, stop, speed, etc. That's our 7 entry points. The init one was at E003, the first thing it has in there. It has a long branch always to init. Well, init is right here. It didn't need to be a long branch, but to keep things common and easy so we never have to change them, because remember, if I change something downstream in this program, it could go from a branch to a long branch real easy. Matter of fact, if you look at the clear screen, it's the long branch, it's 99, and down here the exit is A0. Both of them, if it's a 1 byte address or negative, it's going the wrong direction. Okay, it would be in a 1 byte one, it'd be minus this address. So anyway, we make them all long branches. We never have to change anything. Again, our basic program, we define it at E03. We execute it here at user1. Comes over here to E003, says long branch always to init. Here's our init routine. So no matter what we change from right here on down in this program, we can take this whole init routine, okay, which runs way down here to here, and we can move it down to the end of our program, and it changes the address of everything. Everything would move up, and this would move to the bottom of the program. We don't care. We just assemble it, and the assembler, when it assembles, these addresses are correct. So we can get from the basic program to the routine we want without changing anything or the possibility of where the heck is the address inside the basic program. And we don't need to worry about what's in these routines. We'll talk about it later. That is my suggestion doing how you use entry points. Yes, you're going to use a few more cycles going through BASIC to do it, but the payoff is you don't have the complexity of tracking down all them execute statements and making sure they're correct every time you change something and debugging it when you change them wrong. Okay, so much for part 1. Well, no, let's do one more thing here. Let me run this thing one more time. Now I think maybe you have some kind of understanding of what we're doing. Okay, there's our basic program. Do a 1 to init it again. I'm going to do some lines, which was a 6, and that's fine. That works. That's just a basic program. But now I'll start our program. I've got it knitted out there and got the interrupt vectors and everything set. Now we're going to start it, and it's going to start drawing our little rectangles down there, and we'll do some boxes. And they run at the same time. If I speed it up a little bit, it's easier to see whenever it's drawing. You can watch it as it does its thing, but as this other stuff goes on. So they do run simultaneously, and it's all based on a timer. I'm at 9 to get out of there. It's based on the interrupt timer, and we'll get into that. So you'll learn about interrupts, you'll learn about the timer, and if I may, that will be in part 2. We'll start looking at the code. I think we'll be able to get through all the code in part 2. I don't know how long that's going to be because there's a lot of new stuff, and hopefully in detail enough to where you'll be able to, if you got a basic program, you want to speed it up, you may want to use it to draw sprites on the screen. You may want to do it for changing colors based on, you let your mind wander and think, gosh, what I could do with it, speed something up in assembly language, or it's easier in assembly language, or I'd always wanted to do that. We'll look at some ways of doing that. So I'm stopping this recording, and we'll get to part 2 in a while.